So let's get started with project one. So the first tool that we're going to use over on the left hand side, as you move your cursor over here, you'll see that the square looking icon on the left is called Create Rectangle. I'm going to click on Create Rectangle, and anytime I click on a tool in the toolbar, typically what you'll see is a window will pop up with all of the function of that tool. Now, one thing I want you to make note of, you'll see that my tool window is fairly small. There's not a lot of information. As you open it up, you may see something that looks a little bit more like this. You can see that there are several descriptions of each of the functions within this tool. And it's kind of like a handy help. So as you can see here where it says corners, it gives me a description of what the corners function is in this particular tool. And by very simply clicking on this little pink icon at the top, I can open and close these at will. I tend to keep it closed by default. I can open it up at any time that I want, but I like the window to be a little bit tighter with information very easily read on my screen. I don't have to be scrolling up and down. And by the way, whatever you have this set at by default, every window that you open up after that, the same thing will apply. So you can see starting at the top, I have an option to create either a rectangle or a square. In this case, I'm going to click on square. And you can see it's already established a start point for me. So ArtCAM is making an assumption that I want this rectangle or square to be centered in my material. Now I can set my width of my square to 8 inches, and you'll see that automatically, because it is a square, it changes the height proportionately. I have the option to set a corner radius, either an inverted corner radius or an external corner radius. In this case, I'm not going to do that. And you can see where our center point is set at 6 on the X and minus 6 on the Y. I want to make note of the fact, or I want to make mention of the fact that you see that the Y is a minus 6, not a plus 6. And I just wanted to help you to understand the reason for that. If you remember, when we set up our materials, we set our origin position at the top left corner at 0, 0. When we do that, what it does is it makes all of the Y coordinates minuses. It's not really a big deal. It's just something to make note of. So if you're positioning something on the workspace, you have to remember that you are working in minus coordinates on the Y. If that's not comfortable for you, if you'd like everything to be positive values, then you would have to set your reference point or your origin position in the bottom left. And then if you can think of this being on a grid, everything in the top left corner of that grid, which is basically everything up here in the top left corner past the 0, 0, now becomes positive values. I don't really have a struggle with that, so I typically use the top left corner as my origin, and I live with the fact that my Y coordinates are all negative coordinates. And of course I can change the rotation of this, in which case I'm not. In this case I'm not, but if I wanted to, I could rotate this square on a 45-degree angle or whatever angle I choose. I'm going to very simply click Create. And I'm going to close that window, and you can see that we've created our square, our 8-inch square in our material. Now, you'll notice that it's highlighted in this magenta or purple color. If I click off of this, you'll see that it turns black. That means it's not selected. Anytime that you see something highlighted and it changes color, in this case this magenta color on my screen, that it's an indication that we've selected that. If we click off of it, then we have not selected it. So the next thing we're going to do is we're going to go over here to the left, and we're going to click on Create Circle. Now, when I click on Create Circle, I'm going to use it in a little bit different fashion. As you can see, we once again have the option to set the parameters of our circle, its location, and the radius of the circle that we want. In this case, I'm not going to do that. What I'm going to do instead is I'm going to freehand the circle, basically left click and drag it to draw the circle. But I want you to watch my cursor as I move the cursor over towards the left-hand corner here, the top left corner. Now, when you watch in ArtCAM any change in the cursor, it's an indication that something has happened. There's been some change in the dynamic of this cursor. Now, if you see in this case, you'll see as I move over towards the line, it changes to an arrow. That tells me that I'm locked onto that line. If I move it to the corner, you see it created this sort of set of crosshairs with a square in the middle. That tells me I'm locked onto the corner. At that point, if I push my left mouse button down and start to drag my mouse, I can draw the circle, but it's locked onto the corner. So irregardless of how big or small I make the circle, it's locked onto that corner. So I'm going to make it approximately that size. We don't need it to be exact because we're going to come back and change it in a little bit. And when I'm done, I'm very simply just going to right mouse click. And that right mouse click is a very powerful function in ArtCAM, because what it does is it not only completes the operation, as you can see, but if you look over on the right, it actually closed the pane or the window that we were working in as well. So I'm ready to move on to the next segment of my project. So now what I want to do is, I've established the circle, but I want to change the size of this circle to make it a 2-inch circle. So I'm going to go over here to a tool that you want to get very familiar with. It's called the transform tool. It's this cross with a sort of the lines indicating motion. I click on that, and again, that window opens up on the right hand side. So you can see this is the size of our circle right now. And you'll notice that there is what we call a maintain aspect ratio option here. I can uncheck it or check it. If I check it and I change the width, the height will change proportionately. We'll always maintain that aspect ratio. If I uncheck it and change the width, the height will not change, so the circle will no longer be a circle. So I'm going to keep the aspect ratio locked on, and I'm going to change the width of our circle to 2 inches and very simply click apply. So now we've created a 2-inch circle over the corner of our rectangle. The next tool that we're going to use is right here. It's called Create a Polyline. So I'm going to click on Create Polyline, and I'm going to show you 2 ways that this tool works. First of all, I'm going to move my cursor over here to the left side of my screen, just to the left of the edge in between the outside of my rectangle and the outer edge of my material. I'm going to push my left mouse button down, and with my left mouse button still being held down, I'm going to move the cursor, and as you can see, wherever I move my cursor, it creates that line. Think of it in terms of a pen, putting your pen down on a piece of paper, and wherever you move that pen without lifting it up, it's going to draw that line. And there will be some function for that tool. It's not something I use an awful lot. I just click on the delete key on my keyboard to delete that. I'm going to use the same tool, but a slightly different variation of this tool. And this is one that I find much more functional, one that I use a lot more often. I'm going to go over here to the left-hand side, same place. I'm going to left mouse click to establish my start point, but I've now lifted my finger off the left mouse button, so I'm no longer holding down the left mouse button, and I'm going to move the mouse. And you can see something very different this time. The software's waiting for me to establish the next point, so it's not going to draw anything until I push that left mouse button again. Now I also want you to watch the cursor as I move this cursor down towards the horizontal plane. Right there, you can see the change. That's an indication that I am now locked onto the horizontal plane. If I left click, what it does is it now establishes that next point, so I've created this straight line along the horizontal plane. And as you can see, if I wanted to, I could create several other points, so I could create any geometry that I want. What I'd like to do is just right click, and that establishes the finish point. And now I'm going to go over here to my center and model button, and I'm going to center that line in the center of my material. Now I'm going to do that one more time, only going to do it on the vertical plane this time so you can see it a second time. Click on Create Polyline. Go to the top of the material. I'm going to left click to establish the start point. While releasing the left mouse button, I'm going to go down to the bottom. I'm going to find the vertical plane. Same thing applies on the vertical plane as it does the horizontal. Left click, right click, and center. And now I've created this intersecting line in the dead center of my material. The next tool that we're going to use is up here. It's called the Trim Vector tool. And exactly as you might think it would, if I click on it, it's going to trim off whatever pieces of this object that I've created that I don't want. Now you'll notice as I move my cursor onto the workspace, my cursor has magically transformed into a pair of scissors. I want you to watch what happens as I move the scissors over a line. You'll see how they open, and if I left click, it trims off the line wherever. It basically trims off the line between two intersecting points. So what I'm going to do is I'm going to start trimming off all of the pieces that I don't want. Basically what I'm going to try to do is create a corner with an inverted I'm going to create an inverted corner, which I'm going to use as a border for this project that we're working on. So we're going to trim all this away, and basically this is what I want to have left. Now I want you to notice that right here there's a function called auto join. Now for the purposes of this particular training session, I am not going to use auto join, but the truth is I almost always use auto join when I'm actually using this tool, and I'll show you why. If I close this, you'll see that right now each of these vectors are independent of each other. So if I click on one, each one is separate from the other. And in a normal situation, if I'm creating machining toolpath, that's not a situation that I'd like to have. I'd like to have all of my vectors connected together. So now what I'm going to do is I'm going to drag my mouse over all three of these vectors because they're all independent. Now you'll notice when I do that drag function, I have to drag my mouse. I'm pushing my left mouse button down and I'm dragging, creating this bounding box around all three vectors. If I don't have them completely inside the bounding box, watch what happens. You see, I only selected these two because the bounding box didn't completely envelop all three. Once I have all three inside, now it has all three selected. I'm going to go up here to another tool, which is called the Mirror Objects tool, and I'll click on that. And once again, down here you'll see one of the options is joining mirrored vectors. Normally, I would use that, but in this particular project, I'm not, because there's a couple of other tools we're going to teach you how to use. But normally, I would have that checked off so that as I mirrored objects, that would basically join them together automatically. But what I will leave checked off is this other option, which is copy the original objects. So what I'm going to do is I'm going to click on right, and I'm going to mirror that object to the right. So now I have two mirrored objects exactly the same. And now I'm going to drag my mouse over both of these, and then I'm going to mirror to the bottom. So now I have created this object, basically this inverted corner, or this rectangle with inverted corners. But as I mentioned earlier, one problem that I have. As I click on each of these, you will see that each of these is independent of each other, each of these vectors. Now, if we were creating an architectural drawing, this would not be a problem. For example, if we were doing an architectural drawing of a house, I would be fine for having to have each of the vectors independent. But we're not doing that. We're creating machining toolpath. And in machining applications, it's very important that these be connected as much as possible. So imagine if we were going to machine these independent vectors right now. What we would do is create a toolpath where the tool would come in, would machine this line, then it would lift back out, then it would go back in, machine this line, come back out, and so on and so forth. The problem that you would have is that it would create a situation where the machine would be very inefficient. The problem is that it creates a very inefficient toolpath because the tool has to keep coming in and out of the material, and also we will tend to see some dwell marks as that tool comes in and out. So it's not the ideal scenario when we're creating machine toolpath. So what we want to do is we want to create a situation where all of these vectors are joined together. So I'm going to drag my mouse again over all of them. And the other option, by the way, if you hit the Control button and the letter A on your keyboard, is a shortcut key for Select All. So I'm going to go up here to an option called Joining Vectors. Now I'm going to click and hold the drop-down button, and you'll see that there are 4 options in Joining Vectors. Now 3 of them are grayed out, which means we can't use them. And let's just take a look at why that is. So you see that the first 3 are joining vectors with a line, or with a curve, or with moving 2 points to a common end. The problem is that as you can see by the illustration, it's showing only 2 vectors. So those tools are only designed to be used if we're using 2 vectors, basically joining 2 vectors together. In this case, we've actually got a total of 12 vectors. So the only option that we have then is what's called joining vectors with coincident nodes. So let's just take a look at this tool for a minute and see what it's going to allow us to do. So essentially what joining vectors with coincident nodes says is this. It says within a specific tolerance, in this case, 1/1000th of an inch. Within 1/1000th of an inch, anything that's closer than that, we want those joined together. Anything farther apart than 1/1000th of an inch, we want those separated. So most important piece of information is directly down here where it says currently the number of vectors is 12, but the number of vectors after we join them is 1, and that's essentially what we're looking for. So we're going to join those, close this window, and you'll see as I deselect this and reselect it, now when I click on it, I get a single vector. So now the next thing that we're going to do is we're going to add a line of text to our project. So I click on the text tool, and over on the right hand side you see all of the parameters of the text tool, and you can see that I can open and close these windows. So if I want to access some of this information, that I can do so. So I have a couple of options here. One of them is down here, which I haven't got selected, is to add text to a curve. So if I wanted to add text so it wrapped around a certain object or a curve, I would very simply just click on that object, and then I would have the option to select that curve. And as you can see now, it's selected, so if I was typing the text in, it would now follow that curve. In this case, I don't want to do that. The other option that I will look at right here is the font. So I'm going to click on this drop down under font, And you'll see that I'm going to have the option to select from many different fonts. So virtually every font that's in this computer I have the option of using. Now, let's just take a look at fonts for a minute. You can see that we have several fonts, probably hundreds on your computer, that are going to have these letters TT to the left of it. And TT stands for a TrueType font. A TrueType font basically is a font that's been designed for printing applications. And as you know, we're not printing here, we're actually creating machining toolpath. Two problems exist with some TrueType fonts. Not all of them, but some of them. One of them is that some TrueType fonts are really designed for printing applications and they don't machine particularly well. Think in terms of what you're trying to accomplish when you're creating font or when you're creating text on a project. It's to be read. If you use very scripted fonts or very artistic fonts, sometimes they're very hard to read when they're in a machining application. I just showed you one there. Here's another one that you would probably try to stay away from, because while it would look fine perhaps if it was printed on a diploma, it probably doesn't come off the same when it's machined, because we're adding depth to something that never intended to have depth. The other problem you have with some of these TrueType fonts is that some TrueType fonts will have separated vectors, where as you saw with the last piece that we did when we did this rectangle, we had these vectors that were all independent of each other and we had to join them together. And some TrueType fonts will be constructed that way. And that can be a problem, because it means you're taking a lot of time to edit those fonts. The other problem is, particularly with some scripted fonts, is that you have fonts that overlap each other, where you have one letter that overlaps the other. And once again, the software gets a bit confused by that, and it won't be able to create a toolpath. So I tend to stay away from TrueType fonts. As you get more comfortable with your software and machine, you may find that you can tackle some of those projects that are a little bit more arduous in terms of trying to solve some of those problems. But early on, I try to stay away from that. You're also going to see several fonts that have this @ sign to the left of them. These are typically engraving type fonts that are single line fonts, really not well suited for machining applications. The good news is at the top of the list, you'll see these fonts that have the letter A to the left of them. These are ArtCAM engineered fonts that are designed specifically for machining applications. Now, to be honest with you, I still even tend to stay away from artistic type fonts. For example, I'm not a big fan of something like Brush or Comic. I just find that they're not a well-constructed font for machining. I want something that's easily read. So I tend to stay with sort of more tried and true. Things like Banknote, things like Times New Roman, Swiss Raster. You can see very structured fonts, very easily read. Engraver's another good one. So I'm going to use Banknote, and I'm going to click on that, and you can see that I can set the size of my font up either in inches, in points, or in millimeters. So I'm going to set my font size at 1 inch, and you can see wherever the cursor lands, that's where I'm going to be able to start my typing. So in this case, I'm very simply just going to type in the word iconic. And I'm going to click Create, and you can see it created the word iconic. Let me just move it so it's a little bit more readable. So I've created the word iconic, and now I'm going to click on Center in Model. And now I've centered my text in the middle of my model. And then the last thing that I want to do is I want to transform this to the size that I want it to be. So in this case, it's at 6.1 inches. And you can see that I have an 8-inch area in the center of my rectangle. So what I want to do is maybe make my text a little bit larger, maybe 7 inches. You'll notice aspect ratio is being maintained here, so I'm changing the height proportionately. And I'm going to click OK, so you can see that it's modified my text size to fit into my material. And now I've created essentially the first project. Essentially, the first project consists of that rectangle with inverted corners and the word iconic. Now, it should be noted, even though we took quite a long time to create this rectangle, I could have created that rectangle using the geometry tools very quickly and very simply by simply clicking on Create Rectangle, using a square at 8 inches, and I actually could have created an inverted corner at 1 inch. And it would have exactly created what we wanted, which was the same thing that we took all of those steps to create. The good news is you learned all of those other tools in the process, but just so you know, a lot of the things that we do in the training modules are kind of longhand. There's obviously lots of shortcuts that you can use in the software to do things a little bit more simply. All right, the last step in this process is we're now going to create the toolpath. So essentially we've created our project, our design side of our project, which is the rectangle and the text. And now we're going to go over here to click on the Toolpaths tool. And in the project pane, anytime you click on something in the top section, you can see that it opens up that function in the bottom section. So I want to look at this section right here, these 2D toolpaths. You can see there are 5 of them. I want to briefly explain what each one of these toolpaths does. So we're starting from the left-hand side. You see the first one is creating a profile toolpath. So let's say we selected this rectangle. So if I selected the rectangle and I selected a profile toolpath, what it allows me to do is basically machine along the line that you see that I've selected. So let's say that I wanted to create a picture frame where I'm going to take the center portion of this out and the outer portion is going to be my finished product. Then one of the options in Profile Toolpath is to select inside the line, and that's exactly what I would do. So in other words, my tool would rest on the inside of this line and it would machine all around here so that I would have exactly an 8-inch opening on my picture frame. Supposing that my project was actually a plaque, so that the rectangle was actually the finished product and the outer portion was my waste material. Now I would use again the Profile Toolpath. I would set the depth slightly deeper than my material thickness, and I would machine the outside of this, and then when I'm done I have an 8-inch plaque, which is exactly the size that I created it. The third option might be, supposing I wanted to create a decorative border around our project. So I'm going to select the rectangle again. Once again, the Profile Toolpath, only this time set the depth very shallow, maybe an 1/8 of an inch or maybe even a 1/16 of an inch. But now I'm going to have the tool sit along the line. In other words, the center of my tool is going to sit dead center on that line, and it's basically just going to create that decorative border. So there's 3 different ways that you could use that Profile Toolpath. Each one does something a little bit different, but every one of them uses the same toolpath, just in a bit of a different way. The second toolpath option that you see here is called a area clearance toolpath. So let's supposing that I wanted to clear out an area in the middle of this, not take it all away, but maybe just create a pocket, if you will. So maybe I want to machine an 1/8 inch or a 1/4 inch depth pocket out of the center of this project. Now I'm going to use an area clearance toolpath. So it's going to basically hog out all the material in the center here and machine it right to the outer edges. And that is a area clearance toolpath. I want to focus on this third one here because this is a very interesting toolpath. It is called a V-bit carving toolpath. I'm going to zoom in on the letter C. I want you to look at this corner of the letter C. So you know it's got a very sharp corner here. I'm going to create a circle just to represent what would be a tool geometry. So let's say that this is the geometry of our tool. So this would be, in fact, let's go a little bit bigger. Actually, we'll go to about 0.6 or so. So this would be, assuming a very small tool, this would be, well, just make it approximately that size. So this represents the diameter of our tool. So in this case, this is roughly a 1/16 inch tool. Now, you would think a very small 1/16 inch tool, we'd be able to clear out the center of this letter C, but a problem exists, and this is the problem. Because it's a round tool, it has no ability to create a square corner, and it would be safe to assume that the closest that we could get to this corner would be about here, which means that we have a problem in that it's not going to create the square geometry. What the V-bit carving toolpath does is it basically recognizes the square corners and the geometric corners in an object, and it will machine them out. And essentially what would happen, if I could turn this on an angled view, you'd see the tool swoop out of the material and then swoop back in. And as it does so, and it uses V-bits to do this, the V-bit will create the square corner. It is the only toolpath that has the ability to create square geometry. And so if you're doing letters, text, logos, line drawings, anything where you want to reproduce the geometry exactly the way you see it, then you're going to use a V-bit carving toolpath to do that. In my experience in my shop, I probably use the V-bit carving toolpath 75 to 80% of the time, because I do a lot of decorative projects where I'm doing plaques and signs and that sort of thing, and lots of times there's text and logos on them. And so because of the nature of the projects I do, I find that I use the V-bit carving toolpath an awful lot. The last two are fairly self-explanatory. A drilling toolpath, so imagine you're going to create a cribbage board and you needed to drill several holes. You'd use a drilling toolpath to do that. And then the last one, again, self-explanatory, is an inlay toolpath. So again, the inlay toolpath, supposing I wanted to create an inlay of the letter C, The inlay toolpath will create both the positive and the negative, or the male and female parts, so that it basically machines either a solid core inlay. For example, supposing I wanted to make a cutting board out of black walnut, and then I wanted to put a maple solid insert in, and it's a 1-inch thick cutting board, then it will cut out the 1-inch piece of black walnut. Would cut out the negative. It would cut out the 1-inch piece of maple, the positive, and the one piece will fit inside the other. The other option it gives me is to do a veneer inlay as well. So supposing I want to do exactly that same project, but only as a veneer, I would do a pocket in the black walnut of, say, 1/16 of an inch, then lay the veneer out on my machine, cut the piece out. It's important to note, you've heard me reference cutting pieces out on your Iconic machine. It is important to note that when you are cutting out a project, you need to make sure that you put a sacrificial piece under your material. There's several clamping strategies that you can utilize to secure your piece to the sacrificial board. In my case, I use a lot of 2-sided tape. I find that it works very well. It's quite safe and easy to take the part off after the fact. Just basically use a putty knife or a scraper or a chisel to pop the material off after the fact, and it comes off fairly easy, and just pull the tape off when I'm done. So that's the basic 2D toolpathing strategy. So let's just take a look at a couple of them. So we're going to click on the rectangle, and we're going to select the profile toolpath. Now in this case, what I want to do is I want to create a decorative border around our text. So I'm going to select along the line. In other words, the center of our tool is going to sit on the center of the line. Our start depth will be 0, which is the top of our material. Our finish depth is going to be 0.125 inches. So I'm going to set this at an 1/8 of an inch depth. Our tolerance by default should be set at 0.001 inches, and you can just leave it there. Basically, all the tolerance is saying is that within, in this case, 1/1000th of an inch, it will not allow the tool on radiuses. So anywhere where you see a radius, it won't allow the tool to move more than 1/1000th of an inch. So you tend to get nice smooth radiuses. If you set that number quite a bit higher, what you end up doing is getting sort of choppy corners, because the tool's path is trying to take its most economical way to get around that corner. And if we allow it to, say, take 1/10 inch bites out of this, then it will not create a nice smooth radius. So 1/1000th of an inch for most applications that we work on is going to be plenty high. And then the next thing we're going to do is we're going to click on the profile tool to select the tool that we're looking for. And in this case, we are going to select, we have this general toolkit here. We're going to select a 90-degree V-bit. And the last thing that we're going to do is we scroll down to the bottom of this window, is we are going to set up our material thickness. Now, one thing I will show you just real quick, you see here we have under options, we have what we call the Safe and Home Z, or the Safe and Home section. I'm just going to open this up, and we're just going to scroll down, take a quick look at this. You can see we have what we call the Safe Z. Safe Z is basically when the tool is lifting out of the material to move from one location to the other. So imagine it machines the letter I, and now it moves over to the C. In this case, it sets the Safe Z at 1/2 an inch roughly. So it's going to lift 1/2 inch of the material. I find that a little bit high. I'm going to set that at 0.2 inches. And then we have the Home X, Y, and Z. And the Home X, Y, and Z is basically where the tool will come to rest after it's finished machining. And so the Home Z, or the Home X, Y is at 0, which is where I want it to be. And I'm going to set my Home Z at also 0.2 inches as well. So we'll change that to 0.2 inches. And then the last thing that we need to do is establish our material thickness. So you can see right here we have the option of setting our material Z0 either at the top or the bottom. With the iCarver or with the Iconic machine, we always set the material Z0 at the top of the block. And the model position in the material, although it's not relevant because we're not working with a 3D model, we're also going to set that to the top of the block as well. Basically what it means is that when we use a 3D model, where do we want to reference that 3D model off, the top or the bottom? And the last thing is we want to change our model thickness to 3/4 of an inch, or sorry, our material thickness to 3/4 of an inch. So basically that's establishing what our material thickness is. And we're going to click OK. And we're going to click Calculate. And what that did is it now calculated the toolpath, but we really don't know what that looks like at this point. So what we're going to go do is go down to Simulation, click on Simulation. And you can see in our preview, it's now giving us an illustration of exactly what the project's going to look like. I can do several things with this 3D view, and by the way, I can toggle back and forth between the 2D view and the 3D view, these two tabs here on the top left corner. I can push my left and right mouse button down simultaneously, and I can shift that model left or right. I also use the roller on my mouse. By just clicking in the center, I can roll in and out using the roller on my mouse to zoom in and out to see exactly what my machining project is going to look like. And the last option that I have is if I push my roller down and then begin to move the mouse left and right, I can rotate that part in any direction that I want. So let's go back to our 2D view again. So we've created the toolpath for the rectangle. Now what we want to do is create the toolpath for our text. So once again, we click on toolpaths in the project pane. As you can see, the toolpath operations are still open. We're going to go to the VBit carving toolpath. As I mentioned, we want to create this geometry around this lettering so that it is a representation of the lettering. So we've got those nice crisp corners that we see. Once again, we set our start depth at 0. We have an option to limit our maximum tool depth. In this case, I'm going to select that, and essentially what it means is that the software is going to allow the tool to machine between two vectors until the 2 points meet in the center. So if you have wider vectors, if the area between two vectors is wider, then it's going to take a deeper cut than it would if the two vectors are closer together. In this case, what we're doing is we're limiting the maximum depth to 2.125 inches. In other words, as it begins to machine down, once it gets to 1/8 of an inch, it basically creates a flat plane. We're going to once again click on the tools, and we're going to select the same tool that we used for the first toolpath, which is that 90-degree VBit. This time we don't need to worry too much about the other options here at the bottom because we've already established those. As you can see, our safe Z and our home Z are what we want them to be at 0.2, and our material thickness is at 0.75 inches, so we're all fine there. And we're going to click Calculate. And we'll close that window, and we will do Simulation. And once again, you see that there's the rectangle that we've created with the inverted corners and our text in the middle, and you can see it looks very nice. Last thing that I want to do is I'm going to click on Simulation now. One of the things that you'll note is that you didn't see Simulation here in the project pane, and after we simulated the first time, it does appear. Anytime you make a modification when you're working on a project and you want to resimulate it, it's mandatory that you click on Simulation. And what you want to do is click Reset Simulation. So you can see the screen goes blank. It basically eliminates the last simulation before I come over here to the left and click on Simulate All Toolpaths. And you can see that it recalculates that simulation and it gives us exactly what we want. If I had moved this or changed this in any way, without resetting the simulation, one simulation basically lands on top of the other and it gets very confusing. You can't really tell what you're doing. So you need to make sure you hit the Reset Simulation and then Simulate All Toolpaths. There's a couple of other options that you have here in the simulation. One is, if you see here under Material, I have the option to change what material I want to simulate in. In this case, I've taken a piece of light oak with a horizontal grain, and now you can see what this project would look like if it was machined in light oak with a horizontal grain. The other option I have is I can click here on Depth of Color, and let's just pick the color black over here at the bottom. I click Apply, and this would actually show me what my project would look like if I was going to paint it black. So I'm going to take that back off here for now, and we will go back to our 2D view as well. So we're pretty satisfied that the project is exactly what we wanted, and the last step for us is to create the toolpath or save the toolpath. So I'm going to click back on the toolpath section. I want to point one other thing out before I save the toolpath. You'll notice there's a little plus sign to the left of the toolpaths tab here that wasn't there before. If I click on it, you'll see here are the two toolpaths that we created. If I wanted to edit any toolpath, I don't need to delete a toolpath and recreate it. All I very simply need to do is double click on one of the existing toolpaths and very simply make any changes that I wanted to make. And once I'm done that, click Calculate Now, and it will recalculate the toolpath and reestablish that new toolpath, overriding the old one. So there's no need to get rid of old toolpaths and create new ones. So the last step in the process is we're going to save the toolpath. So I'm going to click on Save Toolpath, and our Save Toolpath window will open. Now you can see that there are two sides to this. One says Calculated Toolpaths, and there's nothing here because all of the toolpaths that we're going to utilize are over here on the right. Now you can see that we've got a Profile Toolpath and a V-bit Carving Toolpath, but they're both using the 90-degree V-bit. So as long as they're using the same tool, I can create as many toolpaths as I want, and it's going to basically continue to machine from one toolpath to the other as a continuous motion. You can see here that it's saving it to my D drive, which in this case is my flash drive. If I wanted to save this to a flash drive, in this case I'm going to click Browse, and I'm just going to save this, at least for now, I'm just going to save this in my Downloads section. And we'll just call this Test 1. And I'm going to open that, and you can see it now changes that destination. So I can change the destination to save this anywhere that I want. And you can see that my file name is Test1, which is what I'm looking for. The machine file format that you want to look for in the toolpath directory, or in the machine file format directory, you can see there are hundreds of them here. At the time of this video being taped, the one that we're going to be using is called GTEC millimeters, and the file format for that is a .nc file. We're going to click Save, and now we've actually saved this one to, in this case, my Downloads file folder. If I wanted to put this directly on a flash drive, I could, and then I could take this straight to my Iconic machine and start machining it. And that's the conclusion of Project 1, the basic use of the geometry tools. In the next project, we're going to look at bitmap to vector conversion, and I hope that you found this instructional video very helpful.